Hi everybody, this is Richard White and I wanted to talk to you a little bit about how you can use Google Docs to write a report for a science lab report, or especially for the rolling objects lab that we're working on in AP Physics right now. So I'm using Firefox here, and I'm going to go into, it works in Chrome and Safari as well. I'm going to go, I'm logged into my Poly account here, and I'm going to go ahead and go into, into my Drive, and I'm going to do a new document first of all. A new Google Doc here. And something you should know right away, I'm not a big fan of the Arial default font here, so I'm going to change that to a serif font here, Georgia, which seems like it would be a little bit more appropriate for something like a science report that's going to be submitted as a PDF. So I'll just put something in here. Rolling Objects Lab. You guys know how to do all the formatting and everything in here. What you're primarily concerned with, or one of the things that you're going to be concerned with in here, is putting in equations, developing equations in here. So I want to show you quickly how to do that. You can insert an equation, and you get this little menu up here where you're doing equations. You can get a new equation. I'm actually just going to, they've already given me the equation box there. So let me take a look. Oh, it went away. New equation. So let me write F net equals MA. How do you do that? You've got your Greek letters here. You've got some operations, math operations. If you want to do the whole superscript subscript thing, I'm going to go ahead and click on math operations here, and you can see that I've got superscripts and subscripts that are listed here. So I'm going to click on that, and it's going to allow me to type F. I hit the enter key and it'll drop down to that subscript, net, and then I'm going to hit the enter key again and it comes right back up and allows me to type the rest of the equation. So that's kind of cool. And then when you hit enter, that's the end of the equation. If you want to do another equation, of course, you can just type in F net equals MA again, or you hit new equation and then whatever it is. If I'm looking at the forces that are accelerating a rolling object down the ramp, that's going to be the force of, sorry, I need to go up here. Force of gravity parallel, so I'll grab that there. The force, enter, gravity parallel, enter, minus the force of friction. Let me go up and get that. Force, enter, friction is going to equal MA. And you proceed like that. You can develop the equations all the way down. Looks like I might have an extra line there. You can develop those equations all the way down the page. I'll do one more just because I'm trying to be a little bit complete here. This is mg sine theta. So I'm going to type in sine, and then I'm looking for theta, which I believe is up here. See a theta there? Oh, there it is. Mg sine theta. Oh, that's a capital though. I think I want the lowercase. Let me back up there. There it is. Mg sine theta minus that force of friction that I'm going to have to substitute in for later on. So let me get that. And you, of course, can copy paste equations. So if it turns out that you're going to be reusing F net equals MA, you can copy that whole equation and paste it elsewhere on the page. So as you're developing your analysis there, you'll be able to copy paste those things to save yourself a little bit of time. But it's beautiful. What's produced there, it looks very appropriate. That's exactly what you should have in your report. Let's say that you want to do a free body diagram for that. If we want to have a free body diagram, we need to insert some sort of drawing. And here again, Google Docs have really improved their support for this kind of thing. So I'm going to click on Insert and choose Drawing. It's going to launch a separate little drawing pane for me here. So I'm going to draw some stuff. For an object in an inclined plane, I guess I'll probably choose something like this, this guy right here. And I can click drag to create stuff there. If I want to make sure it's kind of lined up along there, one of the things you can do is you can choose to make sure that in the grid there, let me see if I can find out where that information is. In the grid, we want to be able to make sure that it kind of lines up along with these data points here. And I haven't done this in a while. Let me just take a look and see if I can find this here. Oh, snap to X. Let's snap to the grid. We'll make sure that we're on the grid. So when I'm resizing things, it'll stick to those little boxes that are highlighted in the background there. It should anyway. Try now that I'm aligned to the grid there, I'm going to go ahead and draw that again. So there's that inclined plane. Sure, I'm going to draw it about like that. It doesn't seem to be aligning to the grid there. Maybe you've got some halfways that you can do there, but that's not too bad. And the reason I'm trying to give it some good detail there is because I'm going to be doing some other things on here. If I want to change the background, I can control click on that and edit information about this. Where is my background? Oh, sorry. Just click on it and you can go up here. If you want to make it a little bit more mundane, or it's a wooden ramp or whatever, you can do that. I need an object to roll down there. Maybe I'll grab this sphere right here. And you can see that you can change the size of the sphere. That's a little bit odd. If you shift click on that, if you shift while you're doing that, then you can see that it's going to move around and retain its spherical shape there. And then you can use the arrow keys. I'm using the arrow keys to move up and down. It shifts by a little bit there. If you find that it's not quite where it should be, looks like it's kind of digging down into that ramp, and you're interested in this kind of attention to detail, if that bothers you a little bit, then you can, I'm holding down the shift key while I use the arrow keys to move it just a tiny little bit and get it adjusted pretty much perfectly there. So obviously you can play around with these things all you want. I need a free body diagram for this thing, so I'm going to include arrows. Let me grab an arrow up here. A line. What kind of line am I going to get? Line with an arrow. Perfect. And what do I have acting on this thing? I've got a normal force, which is coming up from the bottom. And it's putting it at an odd location there. I want to make sure that it kind of is in the... Whoa, didn't want to do that. Command Z or Control Z to undo. I want to move this thing around, so I'm going to click on that and shift that around to get it in just the right location. I almost want to like move it up like that. That looks like it's a little bit more perpendicular, so I like that. That's a normal force coming up. I should also have a force of gravity. Let me get another one of these. A force of gravity coming from the center and going more or less straight down. So there's that guy, and maybe a force of friction. I also need a force of friction that's going to be coming up in this direction, maybe. And I probably want to move that. I'll click on the select and move that down here so that we can see it coming out from that force there. Looks like it's a little bit off, so again I can use the shift arrow key to move around and get it in the right spot there. And maybe I'll even drag this down a little bit so it's parallel to the ramp there. So kind of cool. Gets lost there. Again, depending on your attention to detail, if you want to make that line a little bit thicker so that we can see it much better, then maybe that's a good idea. We get those free body vectors included in there. How about let's see, we're going to tilt our axes and do an analysis. How about some vector components here? Let's finish things up really nicely with some vector components. I'm going to grab here and draw a line that comes out kind of like this. And yeah, I'll make that a weight of 3. And I want it to be a little bit dashed because it's a component. So I'll do that. Maybe a slightly finer dash coming out there. Click on select. Can I draw that out a little bit? Yeah, I'm not sure I'm entirely happy with that, but maybe that's the best I can do right now. And then one more. Well, tell you what, I'll just grab this guy. If you option click one of those things, you can move it out off to the side. That's kind of cool. And maybe I'll just rotate this around so that it's going to be in the opposite direction, and I'll set that up right there so that it's going to combine with this guy down here. And ideally it would go right there. It's not quite parallel, so I can see that I'm a little bit off in my adjustments here, but I'll figure out something that's pretty close to what I want here. And get that adjusted maybe. This tucks in a little bit more there. That's not too bad. I need to make this a dashed line. This is starting to look like a pretty cool little free body diagram. I like that. I need labels, of course, for everything. So click on the text box here. And yeah, text box. This will be for the force normal. And we don't get any, this is a limitation of Google Docs, we don't get any subscripts or superscripts for these text labels in a diagram. So that's why we have to fudge it a little bit rather than saying F sub n. I suppose you could just call it the normal force there. Here's one over here. I'm going to copy that and then paste it. And now I've got another one. Down here's the force gravity. And one more up here. And this will be the force due to friction. If you're using unique names for those things, you could do that. I suppose since I've got these components on here, I'll do one more. I'll say that this is going to be F parallel. And then the last one, F perpendicular. And I'll drag that out. So this is starting to look like a good little diagram. I like this. I like this. I would totally use this. So save and close. And where does it go? It goes in here, and then you can drag it around. Once you've got it there, you can figure out where you want it to go. If you click on wrap text, you can do that. And yeah, move it around wherever you want, or leave it in line. A little bit safer to leave it in line, and then it's not going to accidentally mess up your text there. So cool. I've got a text document with a serif font. I've got equations in there. I've got a nice little diagram. This is looking fantastic. You also need to be able to put a data table and graphs in your document. So let's see how to do that. I'm going to open up a new document in my Google Docs here. Let me go to the drive and get a new Sheets document. Now this can be a little bit tricky here, but presumably you've got some data, right? You've got some data that you've collected, and we are going to, let's go ahead and just, I'm going to go ahead and highlight all three of these and expand this out a little bit. We're going to record that data, so I'm going to say that there's some time period over which we're going here. Should we go with a time? There's a few ways we could do this. Let's say that you've measured out, let's do position. Position in meters. Let's say you've measured that out, and you've got some times then associated with those. So I'm going to put this here. So we've got 0 meters and 0.20 meters and 0.40 meters. So these are positions. Sorry, 0.8 and 1.0. You've got a meter long thing, and you've got these times at which you measured, you saw the ball rolling past those positions. And I don't have any actual data here. Let me get some data. I'll be right back. Okay, so I've got some data here. I've got some times that I put in here. And I suppose the question now is, well, okay, what does that look like? Let me graph that data real quickly. I'm going to select that data and insert a chart. They call graphs charts in these applications here. And I don't want a graph chart or a bar chart or a column chart. I want to go over here and scroll down to this scatter plot here. And you can see that my data is a little bit funky there. I'd probably want to go back and collect this data if I saw this, redo this, because this doesn't look like very good data at all. But this is what I've got. We'll pretend that this is what I've got right now. So let's take a moment, and I'm actually just going to get rid of that whole graph. Let's take a moment and think about, well, if these were the times that I really got, and if these are correct, where, and this is where the ball was at those times, where, according to these times, should the ball have been? In other words, if I was going to graph X meters predicted, because this is what I actually measured. At these times, I measured the ball to be at these positions. I actually did the opposite of that. I saw at these positions that this was the time, but those are equivalent. So if this is where I measured the ball to be at this time, where would I predict the ball to be at these times here? And that's an interesting question. How do I figure out position as a function of time? If you remember, we have an equation for that kind of thing. We say x final is equal to x initial plus VI times t plus 1/2 times A times t squared. So assuming that I have a position of 0 at the beginning when time is 0, and assuming my initial velocity is 0 at time equals 0, I can calculate my predicted position just based on 1/2 times A, and I'm going to say it's a 3.5 meters per second squared. Let's say I'm predicting that, times that t quantity squared. So how do I do that? How do I predict where it's going to be? This is a really cool thing you can do. So check this out. I'm just going to copy this whole thing in. Copy this formula here. I want to put in x predicted here. And the way in spreadsheets you get the spreadsheet to calculate a formula, it's amazing. You type in here the equal sign, which is an indicator that you want to calculate something. And then you type in the formula that you want to use. In this case, though, where is my time? I'm going to get rid of that t there. My time is actually stored in this cell here. So I'm going to click on that cell, and you can see how it enters that cell into the formula. When I hit enter, it's going to substitute that in there, and of course, since the time is 0, it's going to work out just fine. I want to copy this formula down to the next row, though, and if you just click this box and drag it down, something really cool happens. It takes that formula, and let's take a look at that now. It takes that formula and copies down the reference to the time. It's no longer A2, it moved it down to A3. So I'm going to be calculating that same formula with each of these updated times as I go all the way down. Let me just drag this all the way down, and you can see that formula adjusts as we go down there. So this is really cool. This is the power of spreadsheets. I can copy these things down and have it automatically do those calculations for me. Now my data table, my actual data table, is just this part. This is what I would include in my report. But for my graph, comparing what I got compared with what I would predict, I'm going to grab these 3 columns of data and insert a chart based on those. So let me try that again. I don't want that dumb column chart. I want to go down to a nice science scatter plot, XY scatter there. And now you can see I've got some really interesting things happening there. I've got some data that is what I would predict based on these numbers here, and some data that I actually measured there. So what can we do with that stuff? How can I use that to make a kind of a cool chart? I can customize this. I'm going to go down and take a look at the series that I have here. For my series, I'm actually going to include a trend line. The trend line I want to include is going to be a polynomial, because I think this is a second order polynomial. I'm expecting to see quadratic results here. And yeah, maybe I'll show the r squared value just for fun, because that's kind of a cool thing to see. And then, yeah, I've got formulas there. Can I put that? Legend, what's the legend going to have? In the legend, what do I want to have? I want, can I get that formula? Oh, wait, series, trend line, label. Can I do a label? Label, use equation. And that's going to include the equation in there. So I'll actually get equations for these two things. That's pretty good. I should still put labels on these things. So chart and axes titles, if I click on that, I'll get a chance to actually go in and put in the various things there. I can select chart title, horizontal axis title, what should that be? That's time in seconds. The vertical axis is going to be what? Vertical axis is going to be position in meters. And so I've got those things on there. This is pretty cool. And maybe I'm going to change the title there. Sorry. Let me go back up here to chart title. And I'm going to replace that. It auto-filled that. I'm going to say position time for a rolling sphere, angle 30 degrees or whatever it worked out to be. put a 30 degrees in there. That's kind of cool. So here's my chart. I got a good looking chart. This is awesome. And notice these R values here. These R values indicate how close my data is to being on this trend line. And for the data I collected, my R squared value was a 0.981. That's okay. I had some outliers there, some misses. I'd probably want to go back and collect more data if I saw that there, but it's not bad. You can see that for the brown line there, that's the predicted, it matches perfectly. That's because we used a formula to create that. That's not so much a trend line, it's just a graph of the formula. So not surprised that that matches those data points really well. Those, in fact, aren't even actual data points. They're fake data points that I used to create that line. And if I could get rid of those data points, I probably would somehow and just leave the line there. I wonder if I could do that. Color, point size. Oh, let's make the point size none. Oh, that's really nice. Now I've actually got a trend line there that doesn't have data on it, and that allows me to focus on these data points. That's the best. How do I get that into my document? I'm going to click on those little three arrows there and say Save Image. And I can save that image as a PNG file called chart.png. Maybe I'll just save it someplace on my computer. That might be a cool thing to do. What else can I do? Can I actually, how about if I do this copy chart? Oh, and they just tell me to Command C for copy. So I'll select it, Command C, and then let me go back to my actual document. If I can get over to my drive here. Sorry, here's my untitled document. And I'll just paste it in there, Command V, paste. Do I want to link or unlink? I think I'll unlink it and just paste it straight in there. And now I've got an awesome looking chart for my report. Well, it was a little bit of work to explain all that to you. It actually goes a little bit more quickly when you're just doing it. But this is a great start to the Rolling Objects Lab. So I hope that's helpful. If you have any questions, please come see me and I'll help you out. Thanks. Bye.